In this, we're going to review some of the laws of logarithms of multiplication, the quotient law, the power law, and then we're also going to look at change of base formula for logarithms. All right, so let's go ahead and get started. If we have subtraction of logarithms, that can combine to be division. So that's the quotient law right here, okay? But this one, there's two different things that are being subtracted. So first, what I'm going to do is just go ahead and factor out that negative, and then I'd have log base 3 of 18 plus log base 3 of 50. Okay, and I don't need to write that -1. I'm just factoring the negative out of both there. Now I'm going to go ahead and simplify in my parentheses. I have addition of log, so I'm going to use this logarithm law right here, where if I have addition of logs, that can get combined as multiplication of those two arguments. So let's go ahead and simplify in here. That would be log base 3 of 18 times 50. And I'll copy the rest of this down. Log base 3 of 100 minus all of that. Log base 3 of 18 times 50. So now we can go ahead and deal with our division. And we'll use that second law now here. Okay, so we've got division of logarithms. That means that I can combine as division within the argument. So I would have the first thing, that 100, that goes in the numerator, and then the second thing, that 18 times 50 is going to go in the denominator. All right, and then I'll go ahead and simplify this. 50 goes into 100 2 times, so then that would be log base 3 of 2 over 18, and I'll go ahead and simplify that as 1/9. Great, okay, and now we can use our third law right here. So we have log base 3 of 1/9. Well, since 1/9 is the same thing as 3 to the -2, then this whole thing simplifies down to that exponent of -2. Great. Okay, so this one looks like it's set up in the same way, except I do notice that I have different bases here, and so I'm going to go ahead and just see if I can simplify a little bit. I don't have the same base. So let's just work on this first one. So log base 3, well, 27 is the same thing as 3 cubed. And then this next one, log base 3 of 1. Log base 3. 1 I could think of as 3 to the 0 power. So that's just going to simplify down to 0. Okay, and then finally this last one, remember that ln, natural log, that is log base e. Okay, and then the cube root of e is the same thing as e to the 1/3. So that'll simplify down just to 1/3, and this first one would simplify down to 3. So it would be 3 minus 1/3. Let's get a common denominator. So that would end up being 9/3 minus 1/3, which is 8/3. All right, let's work on our next ones here. So we're supposed to now expand all the way. Okay, so the first thing I'm going to do is rewrite that. Instead of a cube root, I'm going to write that as the whole x, y, z squared. That is being taken to the 1/3 power. And then I'm going to apply that 1/3 power to everything. So it'd be of x to the 1/3, y to the 1/3, z squared to the 1/3. We get to multiply those two powers. Z squared to the 1/3, we would just multiply that 2 times 1/3. So that would end up just being z to the 2/3. Okay, good. And now I've got multiplication in my argument, so then I can expand that out as log base 5 of the first part plus log base 5 of the second, so y to the 1/3 plus log base 5 of the final part, which is z to the 2/3. And now our exponents get to come out in the front and become coefficients. So it would be log base 5 of x plus 1/3 log base 5 of y plus 2/3 log base 5 of z. All right, so that is completely expanded out, and we are done. Okay, let's try this next one. I see some division. So let's do ln of a minus, so it's the numerator, and then we would take ln of the entire denominator. So it's b cubed. That c, the square root of c, I'm going to write that as c to the 1/2. Okay, and now I have multiplication in that second argument, so it would be ln of a minus ln of b cubed plus ln of c to the 1/2. And we're going to, that's like having a little -1, we're going to distribute that negative to both. So we would get ln of a minus ln of b cubed minus ln of c to the 1/2, and then those exponents get to come out and become coefficients. So ln of a minus 3 times ln of b. You don't need those parentheses around the argument. It's just whether you prefer it or not, ln of c. And we are done. All right, let's do 2 more examples, and then we'll look at the change of base law. So in these 2, we're going to actually combine them down and into a single log. So let's see, I've got I've got these coefficients. So these are going to come and get to be exponents. Up they come. So we'll have log base 3 of x minus log base 3 of y cubed minus log base 3 of y to the 1/2. And then, let's see, I'm going to go ahead and factor out that negative. So I'm going to keep my log base 3 of x in the front, and then I'm going to factor out a negative from log base 3 of y cubed, and also from log base 3 of y to the 1/2, log base 3 of y to the 1/2. Okay, next part, let's deal with our addition here. So I've got log base 3 of x minus log base 3. Addition of logs means that I get to have multiplication within my argument. So it would be y cubed times y to the 1/2. And we get to combine our exponents there, 3 plus 1/2. So log base 3 of x. Okay, so get a common denominator. Let's see, make it halves, so it would be 6, 7 halves. And so I also have subtraction, so I'll go ahead and make division within my argument. So it would be that x is in the numerator, and then the second argument is in my denominator when I'm subtracting. So it would be y to the 7 halves. Okay, let's do our next one. So I'm checking to make sure I have the same base on all of them, which I do. Okay, so the first thing is I'm going to bring my exponents up. So I'm going to have ln of a squared. Now I have addition. I'm going to just use commutative property and just move this ln of a plus or a minus b. I'm going to just move that next in the middle here, ln of a minus b, and then we'll have ln of a plus b. Okay, and now I have addition, so let's go ahead and combine that addition of logs. That means multiplication in the argument, so it would be a squared times a minus b. And now I have subtraction of logs, so that combines into a big division of the argument. So it'd be a squared times a minus b in the numerator, because that comes first. And then we're subtracting ln of a plus b, so the a plus b goes in the denominator. All right, and that one is done. Okay, so now this might be new for some people, depending on what algebra class you took before this. So this is the change of base law, and I'm going to go ahead and prove it for us. So The law basically says if you have, if you want to change from one base to a new base, what you do is you take the new base and then you divide it by the new base where the old base is your argument in the denominator. Okay, so let me go ahead and show you why that works. So I'm going to let y equal log base b of x. So using the definition of logarithms, what that means when we rewrite it as an exponent would be that b to the y power, right? We have the base to the y power is equal to the argument. Okay, now what I'm going to do is take the logarithm base a of both sides. Okay, so I'm going to take log base a of the first side and log base a of the second side. Okay, now we're going to use property 3, where we can have that exponent inside a logarithm that can come out and become a coefficient. So it's going to be y times log base a of b. We'll just copy the rest of the equation down, log base a of x. And then we can go ahead and divide both sides. Okay, so I'm going to go ahead and divide both sides by log base a of b. All right, so now we have y is equal to log base a of x divided by log base a of b. And now we'll use substitution. And because of how we originally defined our y, we'll substitute that in. So that tells us that log base b of x is equal to log base a of x over log base a of b. And that was what we had set out to prove, and so we're done. QED, what we set out to prove, we proved. So let's try this with an example. So let's look at, our calculator doesn't do log base 5. So if I wanted to actually try and figure out what this was worth, what I want to do is change this to a natural log. So I'm going to try, so my old base is 5. Okay, so I want my new base to be e. So I'm going to take log base e of my original argument divided by log base e of my old base. Okay, so that's ln of 62 is equal to ln of 5. And then you can do that on your calculator, and that's approximately 2.5643. All right, so that change of base formula is really going to come in handy when we're trying to solve all kinds of different logarithms, because our calculators only can do log base e and log base 10 for the most part. Okay, so on these next ones, I encourage you to pause the video and see if you can come up with the answer on these for yourself. Okay, I'm going to give you a little hint. Think of 2 as 2 to the negative 1/2. Think of 8 as 2 cubed, and then simplify. Oh, I don't want an equals there. I want a subtraction. So this would be ln of e squared to the 5th root. That would be to the 2/5. Okay, and then use your what you know about exponents coming out and becoming coefficients. Oh, hang on. One little thing, that should be 1/2. We want the same base. Okay, so 2, I'm going to rewrite that as 1/2 to the negative 1. All right, so pause again, see if you can come up with a solution here. All right, and I'm wondering if you were able to come up with negative 22 fifths. Okay, let's try a next one. Give yourself a little bit of time to think about it and see what you can come up with. On this one, you are going to expand this out completely. So you're going to be left with a really long expression. Okay, go ahead and pause and write it down and see what you can come up with. Okay, I'm going to write that square root as 1/2, and then I'm going to apply that 1/2 to each term. Then I'm going to use my the second law, or the first law, where we've got multiplication in the argument, so that can expand out as addition of logarithms. Let's see, log base, 3 of beta the 3/2. Okay, use what you know about exponents inside a logarithm. Bring that out as a coefficient. You're going to need to do a little work with your 27. You're going to need to rewrite that as 3 to the 3rd. Okay, so instead of 27, I'm going to rewrite that as 3 to the 3rd. And then that exponent gets to come out as well. So that'll end up being 3 times 1/2, or let's see, 3/2. And then this would be plus 1/2 log base 3 of a to the 1. I dealt with my exponent. And this will be 3/2 log base 3 of b. So we'll just bring those down, and we finally got 3/2 plus 1/2 log base 3 of a plus 3/2 log base 3 of b. And that is done. All right, one more for you. See what you can come up with on this one. I gave you the answer here, so see if you can come up with that answer. Go ahead and pause. Okay, I've got subtraction in 2 places, so I'm going to write this as ln of x squared minus 2x minus 3 minus ln of x minus 3. I'm going to go ahead and bring this exponent up, that 2, and I'm, let's see, factoring out that negative. I don't need, I was trying to do it all at once, but I don't need to. Okay, and then plus ln of x plus 1. Okay, and then we'll simplify that multiplication, so it would be ln of x minus 3 quantity squared times x plus 1. And then I have subtraction, which I'll do next. Minus 3. Minus. Okay, so then we'll have division in our argument. And let's go ahead and factor that. That can factor out as x minus, x minus 3, and then x plus 1. And then we'll have x minus 3 quantity squared times x plus 1. Okay, and then we can simplify a little bit. X plus 1 divides to x plus 1, and then anything divided by itself is 1, so one of these will cancel with one of these, and we're left with 1 in the numerator and then a single x minus 3 in the denominator. So it'd be natural log of 1 over x minus 3.